Number 14 is a question on material from the second exam regarding acetals and hemiacetals. Now this question is a favorite of the professors. I have seen this question show up in some shape or form every year on at least exam 2 or the final. Now, I'm not going to say this is going to be the exact question you get, but there's going to be something probably like it. And the thing about this question though is it's very long and time consuming. So if you're pressed for time on the exam, save this for the end because it's one multiple choice question. Now how do we go about solving this? The first step is to protonate because we have H+, and so we have some options. Do we protonate the OH or one of the oxygens in the ring? In general, you're going to protonate oxygens in the ring because if you protonated this, it becomes H2O positive and then nothing really happens beyond that point. But if you protonate one of these oxygens, let's start with the labeled one, the O18. Well, now that this oxygen is protonated, it can actually, the ring can break. Let's see how that happens. So I draw out the structure with just that oxygen now protonated, and so that oxygen becomes positive because it is protonated. Okay? And what will happen is this oxygen can now swing down, forming a carbon-oxygen double bond, and kick that OH positive out. And as a result of that, you will get double bond, two methyls there, double bond O positive with the rest of its chain. Now I should probably number my carbons because I'm bound to make a mistake if I don't. So let's say this is 1, 2, 3, 4, 5, 6, and 7. And I'm numbering the oxygens as well because I'll probably need to keep track of those. Now, oxygen 7 we'll keep in mind is the O18. So I'm just going to write O7 equals O18 just so we don't forget for later. Okay, and now so I have oxygen, I have 1, 2, 3, 4. 4 is bonded to the OH that I labeled 8. Then I have 5 with a methyl, 6, 7, and then and 7 is the oxygen that we care about. So that's the O18. And it's OH neutral now. And this is 7, 6, 5. Okay. Now what can happen from here is this carbonyl, we have a double bond O positive, and whenever you have double bond O positive, something likes to attack the carbon. If we have the O18 that we started with attack, we just end up reforming what we started with. But you do have this oxygen over here available to do that attack. So this oxygen could use its lone pair, attack there, and this would swing up. And now what would you get? You would end up getting another ring. Now let's count how large that ring would be. This oxygen is doing the attack, so I'm going to start counting from there. 1, 2, 3, 4, 5. I'm making a 5-membered ring. So I can just start by drawing a 5-membered ring, where one of those members is the oxygen, because the oxygen ended up attacking this carbon. And then this oxygen was already part of that chain to begin with. Now let's see, so that was 1, 2, 3, 4, and this oxygen we said was 8. 4 also has carbon 5 with a methyl, a 6, and an OH. And that OH is the the O18 that we're paying attention to, 6, 5. So this is one possible answer. Now we look at our answer choices and see, is that a possibility? Well, we said O7 was the O18 that we labeled, and if we look at the structure that I just drew, this is in fact structure 3. And now I got lucky. I chose the right oxygen to protonate on a 50-50 bet, because I could have protonated this oxygen and had to go about the problem that way and see what the possible answers were. And you would, if this was your question, you're taking the exam, you would still have to do that because they gave you 2 other options and they gave you options of more than 1 being the correct answer. So I have to actually still consider that. But for now, we know that structure 3 is a possible answer. So at the very least, we can say the answer is either C, E, or F. 3, 1 and 3, or 2 and 3. Now I didn't draw out the structures of 1, 2, and 3, but I'm assuming you have the answer key in front of you so you can look along, and if you don't, you can probably pull it up because I don't want to draw those. Anyway, so what I'm saying is, there's a possibility where if this is your exam and you didn't get lucky, you chose to protonate this oxygen first. And you'd have to look at what possible product you can make out of that. So it's kind of the same process at this point though. You have these 2 oxygens, you have your 7-membered ring. Now this is an OH positive instead, and we said this is the O18, but I'm going to number 1, 2, 3, 4, 5, 6, and 7 again, and then this has a methyl, this has an OH. This time it's the O18 that forms the double bond to kick the regular OH out, And now I've broken the chain, so I have this bond gone. This is now double bond O positive down this way. The carbon chain to 6, 5, 4, 3, and then the OH that we picked out. 4 has a methyl, sorry, 4 has an OH, and 5 has a methyl. Now let's number this 1, 2, 3, 4, 8, 5, 6, and 7. And now, since we don't want to reform the ring we just started with, don't have 2 attack 1. Have 8 attack 1, and consider the ring that makes. So this would make a 1, 2, 3, 4, 5, 6 numbered ring. And right off the bat, if you look at your answer choices, there's no 6 numbered ring. So you could just say, okay, this isn't a possible answer and be done with it. But on your exam, they might give you more than one choice. But the point I want to make is these questions take a while because clearly you have to consider both oxygens. One might just not be an answer altogether. And it's kind of a mean move on their part, but it's their exam to write, so they can do whatever they want. And so let's just draw out what that would look like if we wanted to see. So I have a 6-membered ring, and here is 1, 7, 6, 5, 4, and 8, and then 4 has 3 and 2 coming off of it. So this would have been the other possible answer, which was not an answer choice on the list. So the answer for this question was C. Only structure 3 worked.